Hey, you're yours, right?
Hey, yeah, that's perfect. Better every time.
Yeah, look, I'm half Greek right now already.
Were you in J Crete last week?
No, last week I was in Seattle, I think. But
Oh, cool.
yeah, almost in Crete. But we had a chat about, actually, where we stopped was about Quarkus and AI.
Mm-hmm.
And I
Correct.
believe that you are actually working on LangChain4J right now.
Yeah. So I'm working on the Quarkus side, and yeah, that involves some work on upstream LangChain4J as well. Yeah.
Uh-huh. And so how it happened? I mean, we had a conversation about, Rest Easy and JAX-RS, and
Mm-hmm.
now you so since when you are working and how it happened? Yeah, it's interesting.
Yeah, absolutely. So yeah, it's an interesting story, really. So like since let's say what was it, like November 2022 with ChatGPT and the Mid Journey stuff and all that, like everybody was like trying to figure out, let's say how we could add AI to our stuff and things. Different people were prototyping and like doing little hacks here and there, I guess. I saw that stuff and was like, yeah, okay, it's okay, but it didn't really like pique my interest at the time. So like fast forward then to DevOps Belgium 2023, so like 10 months ago or something like that. We were there. We were doing like a Quarkus workshop, so nothing AI related at the time. We didn't even have any Quarkus or for that for that reason, even Red Hat story around AI. So we were just like showing regular Quarkus stuff. And then, so I think this was like the on Thursday, so this is the day before the conference ends, there was a presentation about LangChain4J from Lisa.
Hmm.
So she's part of the LangChain4J team, and she presented. I think it was like probably like the first time LangChain4J was presented there. I wasn't at the talk; like I had some work to do, so I was like sitting outside, in the hall room, doing some work or whatever. But once Dimitri, so Dimitris Andreadis, he's been on the show. He's my boss's boss. He was at DevOps Belgium. He was at the talk, and once the talk ends, he comes out. He finds me there, like typing away or whatever I was doing, and he's like, "Drop everything you're doing. We need to focus on this. This like he's like, this is the future. This is how we integrate AI into Java and Quarkus." Like he was like amazingly excited about this. And like at that point, like I hadn't even watched the talk. I didn't even know what LangChain4J is. But he's like, you know what? Like we really need to start something here and show these people that we're serious and we really want to invest in this ecosystem. So I started like looking at the tutorials, looking at what they had, and the idea of the Dimitris was that I didn't actually know the whole story at the time. Was that the next day, so Friday, last day of the conference, he and a couple other people from Quarkus were going to talk to LangChain4J folks. So there was Lisa, and there's also Dimitro, who is the creator of LangChain4J. Obviously, he's been on the show too. They were going to talk on Friday morning. I couldn't be there because like I had an early flight on Friday, so I had like a few hours to Thursday evening to like put something together and show like how we can integrate Quarkus and LangChain4J. But like once I started looking into this stuff and like seeing the examples that Lisa had presented, I got the same feeling that Dimitris had, right? I'm like, wow, yeah, this like absolutely makes sense. These are these are great abstractions. This is the way that we have to integrate like AI stuff in Java. So I put together like a small like prototype of Quarkus LangChain4J, like very basic stuff. Whatever I could do in like a few hours, right? And then Dimitris and talked to the LangChain4J folks next day, Friday morning. I guess that went really well. And then, like, once I got back from DevOps Belgium, like next week, we started like really working on it and really hashing out what a Quarkus specific LangChain4J story would look like. And it took like a few weeks of work, and before we released like our first version of the extension.
I was also in the talk, LangChain4J.
Oh, you
But
were.
yeah, I was also in Belgium. But I had the impression that Quarkus already supports that. This was the interesting part. I saw. I was in the talk. So okay, I can imagine how it works. And then where I really saw it was in February. I was in Devox CERN. There was also Liz. Or Lisa, and she had a Quarkus hoodie, and had a chat with her. She go, we really love Quarkus, right? So it really happened fast. Like 2 months later, it was fully integrated. So, but now maybe my summary. So from my my impression of LangChain, not necessarily LangChain4J, but LangChain,
right,
is a bit boring. So how I would describe it is like a pragmatic ESB for LLMs, right? So what you can do, you can very easily abstract LLMs. And why I told you boring is because mostly, in most cases, not all, but in most cases, it is very similar to microservice abstraction, yeah, right? Because the LLMs, they are available via HTTP API. So I think even we could use LangChain4J as an ESB without LLMs, right? We could actually use LangChain4J for microservice integration. Should work.
Yeah, I mean, well, that's exactly it, right? It's an abstraction layer on, and it's very basic, right? Like the basic abstractions are like abstraction layer on top of LLMs. And it's interesting how you say ESB, but some folks in Red Hat consider it like hibernate of LLMs. So
yeah,
the idea is that it brings like the boringness, the easiness, let's say, to Java development for LLMs, and that's exactly what I think it's very good at.
Yeah, but I would say Hibernate is wrong. It will be JPA.
Yeah, correct. Yeah.
Because because JPA would abstract Hibernate and OpenJPA and a top link, for instance, or Eclipse link. Okay, so what you did the first night, the 5 hours or whatever you had.
Yeah. So the first few hours. So
the first commits. What you did exactly? So
yeah. So the whole idea was okay. Like there's only so much you can do in a few hours, right? So what I hoped to do was make make some of the abstractions like the chat language model, embedding model, stuff like that. Like make those beans, like CDI beans, and make them configurable with the Quarkus configuration property. So Eclipse microprofile property. So that was the whole idea. Like show how the LangChain4J abstractions can be integrated into the Quarkus programming model, like relatively simply in a first prototype, right? So developers don't have to like care like to set up the chat language model and blah 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 all that stuff and configure it. Like they just use the Quarkus mechanism and then things just work automatically. So that was the idea for the prototype.
So you created producers for CDI beans.
Yeah, exactly. Yeah, and configuration that like mapped onto what the LangChain4J models needed for like configuring temperature, model ID, stuff like that.
Okay.
So yeah, that was the idea.
Okay. Because the really cool part is that actually microprofile and the Quarkus, they fit extremely well to LangChain4J and LLMs. This is the surprising part, and this is accident, I would say. Why? Because of the injection and because of the scopes. So this is why it really fits well. So I would say the simplest possible abstraction for, let's say, ChatGPT, this is, everyone knows ChatGPT, is, I think, an interface with AI service, right? Annotation and system prompt and user prompt, two other annotations. And if you will inject the interface, and what's also cool is you have a kind of variable replacement or template replacement. So you can have in the user prompt a placeholder with curly brackets, and then you can, if the name has to be the same to the parameter of the method,
Yes.
which is already interesting because what you have to do is, right, you have to run Java in specific mode, I guess. Otherwise, you won't see the names, right? So it's interesting.
Yes, that's a good point. Yeah, I can explain. Yeah, but yeah, that's the idea. Yeah.
And then you are done. So it means your 3 lines of code. You can use ChatGPT. And the cool part is all the credentials can be stored in your environment. So you can already ship a clean Quarkus, check it in somewhere, and then you can inject this what you did to all other services. I refer to boring because this is very similar to microprofile REST client, right? So if you would integrate another service, you would do similar things. So without the nice support of the placeholders, so you would just have an interface with get or post annotations and path, and then you can inject and it will work. So it's similar, right?
Yes, it's very, very similar. That's a great analogy. And I think the point you made that like it's by accident, it fits very well. It is like obviously this stuff was not designed for LLMs in mind, obviously because they didn't exist back then. But what I think has happened here is that the Java ecosystem has had 25 years now, and the enterprise space around, I don't know, 20 years, whatever. It has had all this time to evolve and mature patterns that make sense in a whole bunch of scenarios, right? And we figured out like what the proper separation of concerns are, and like how we deploy to production and stuff like that. So I think that like obviously it was kind of serendipitous that it just fits in. But on the other hand, it makes sense that it's a validation that these patterns that we've come up with all these years absolutely make sense, right? And I don't know how other ecosystems work, like Python and JavaScript. Like last time I coded in other environments was probably like 6 years ago, so I don't know where they are right now. But I'm hard pressed to imagine like an environment that is more cleanly separated and easier to work with than what we have in Java in 2024, right?
I had a bit of experience because the first time in my history I had to to port Python to Java, and the first time was forced to really look at Python. And this Python already used the LangChain, not the 4J, rather than Python's LangChain, and then a custom LLM. And it was understandable for me. And I ported to Java. And the interesting part now is, but it was not Quarkus nothing. It's just plain Java 21. But the cool story is the resulting Java was shorter.
Yeah,
this was
funny.
the cool part. Yeah, that's really funny. This was a huge file. And I said, okay, let's try it 1-to-1, right? Because say Java is verbose, and let's see what happens.
Yeah, exactly.
So and Python used, for instance, I remember dictionaries or something like this is similar to HashMap. And I say, why they are doing this? Because they created the dictionaries and then send the dictionary as JSON. So what I use in Java, right? I use the text blocks with placeholders, and I was done. And I say, okay, why they are so complicated, right? And this was, but then there was a little bit. Everything was in one file. So the exception handling was not well done in Java, and neither in Python. So in Python, if something happened, you get a strange error. So let's do it in a proper way and split it into several files, which was a way nicer. And then I thought, I really don't understand. What's the problem, right? Because in this particular case, I think it was more or less Pythonic, but Java was simpler. And this was my recent, maybe a few weeks ago, my recent experience with Python in Java. And what I do, I usually start to work with LLMs just using Java HTTP client first. And I think the unique LangChain4J features we talk soon, because there's, if you would like to do more stuff like, let's say, index a larger text or something like this, is really boring to do it by yourself, or really tedious, not boring.
Exactly.
It's not boring. It is actually labor intensive to do it by yourself. So what I'm waiting for now is the revival of conversation scope. You remember conversation scope?
Yeah, I've never actually used it.
The idea was this is a subset of session scope. So you would book a flight and book a hotel, and there will be the conversation within the session. So it's like a partition of a session.
Okay.
And you could have something like this for LLMs, right? So you have one conversation memory with ChatGPT, another conversation memory with Claude, and both are part of the conversation. So I think this would fit perfectly, but somehow, not yet, right? So, but the conversation scope is exactly what conversation memory is supposed to be.
Yes, absolutely. So I do fully anticipate that we will get there. I also want to say that based on this work we did with LLMs, right? We actually had a very, very good incentive to massively improve our WebSocket support in Quarkus, right? Because up until now, like we had the WebSocket stuff, it was not great. It was like rough around the edges, but it didn't have like a huge appeal to people, right? But now with the LLM stuff and like with everybody like trying to build a chatbot, whatever, we really saw that you really need to have a very good WebSocket story that is very similar in how it's used in the programming model to like the Quarkus REST model, right? So like all annotation based and easy to use and blocking or non-blocking, all that cool stuff. So based on the fact that we really needed this, because we had demos with like the old WebSocket stuff and LLMs, and like that there was just too much boilerplate code and too much stuff that people had to figure out how to do manually. It was just terrible. So we're like, yeah, we need to improve this. So we Martin Kuba from the team, who is our CDI expert, he did all the ARC stuff and a bunch of other stuff. He went and after like a design phase that we had, he went and implemented a new WebSocket layer on top of Vertex. So again, like the same IO layer that we were discussing earlier in the last episode. He went and created a new WebSocket layer that is just it just fits so well with LLM. So like if you do like register AI service, like you write that interface, register AI service, and you add session scope, then you just plug that into the WebSocket thing and everything just works automatically, right? So then I did some work to like clear the memory automatically and stuff like that. So it just fits in so well. So what you're saying now with conversation scope, I think would be like the next level. Like driven by that need, we will then be have an incentive to go and improve Quarkus even further, right? And that's what I love about this, that it's not only the standalone thing. It has given us like the opportunity and the incentive to further improve various areas in Quarkus as well.
Mm-hmm. Okay, so let's talk about the basic abstractions. We had one, this is the AI service, which basically is abstraction of LLM. So, and what the Quarkus4J are doing, they have lots of implementation of the AI services, so you can talk out of the box to most of the LLMs. They can be remote or local. So you can talk, to ChatGPT, which is a closed model, so there is no source code or bedrock, or you could also talk to local Llama Java, which should be also available now. And then you are basically done. So you can actually have a JAX-RS service with one line of code, and you have already a chat abstraction. Interesting with the WebSockets, I ignored actually the interactive part completely because in my projects, the LLMs are hidden. So usually they are not returning, tags rather than true, false, valid, invalid, enums, JSONs. So I have to wait until everything is complete. So, but for the interactive user model, for chat abstractions, WebSockets are crucial. Otherwise, So, okay, so what will be the next most important? I think the conversation memory, right, is the next one, or
yeah. So chat memory, like that is super important. It's hard to convey how easily things can go wrong by just talking or even doing a demo. Where you actually see this go wrong is when you actually have like a lot of users talking to the LLM at the same time. That's where you really need to be careful about like which conversation, as you mentioned earlier, belongs to which user. Because if you're not careful, you could, like the default for LangChain4J is like to have like everything goes into the same bucket, and then you would get interleaved conversations everywhere, and that's just plain bad, right?
The same problem we had for years in Java, right? So we have multiple users who just separate from each other, and we have the state on the server. So
yeah, exactly.
So you remember JSF? You've ever worked with JSF?
Yeah, JSF. I used JSF my first job, and like I think that how the team was using it was not proper, but I was not an expert, so
but JSF problem, right?
Yeah.
So there was a stateful, and several users have their own small context, and you have the same problem right now. So it means the chat cannot be global.
Yes, absolutely. Yeah, it absolutely can't be global. So you have to handle the memory per chat, which in LangChain4J you have the chat memory, but how each distinct chat needs to have its own like memory ID, right? So it can like index which things to use in the memory. Because as to take a step back, what we have to say is for people who perhaps haven't fully grasped this, is that all your interactions with ChatGPT or whatever other model, the other model is the model is totally stateless, right? It doesn't know about your previous conversations. So every time you have to send it the whole conversation in order for it to understand what it's supposed to do at this point, right? So it's totally stateless. Just like, let's say HTTP is totally stateless. When you send something, it doesn't have your previous state. You have to build it in. So that's what chat memory is in LangChain4J, and
yeah, but what the chat memory does is, or conversation memory is, because it's stateless, we will have to resend more and more data. So we are sending everything. What we ask the answer from LLM, we ask answer. This is like an array of messages which is sent over and over again, right? So this is how you deal with it.
That is exactly what it is. Yes, and if you like turn on the JSON logging when you're using Quarkus LangChain4J, we have a property that turns on the logging for request and response. You see exactly what happens, and that is exactly what you described. Like you send an array of messages where each message has a type, like whether it's coming from the user or the LLM or whatever, and you just that array just keeps on growing until like you hit a limit, or you have a strategy to like limit how many entries you send and stuff like that. So that's where things like get more complicated that you don't usually see in demos, right? In demos, you just see like small interactions, so the memory is perfectly fine to keep sending the whole thing. But as your conversations get larger, if they do, and in a lot of cases they won't because they're like one off, but in cases that they do get larger, then you have to figure out like, okay, how am I gonna trim the memory? Like, what am I gonna do? Am I gonna remove like the first messages? Am I gonna remove like last messages, or am I gonna limit based on token size? All of that, developers would need to figure out for their specific use case, right?
And the interesting part is very similar to cache problem, right? Because we have memory cache, right? So it will blow up our memory, and now we don't have a memory problem on our side rather than the context window of the LLM, because there are different LLM types, and in one point of time we cannot submit more. We get an error from LLM because the context window is full. So what we will have to do is to think about different strategies, right? Remove the old messages or what we do, because we would like to keep the conversation going, but we would like to keep also our context. So so I would say this is the first true added value of LangChain4J, because implemented by myself is maybe cool first time, but then boring, right? Yeah, yes. I mean, this is a nice problem we solve multiple times, and I would say, almost InfiniSpan problem, right? Almost, I would say.
So, yeah, absolutely. And
how to hook the AI service with chat conversation? So what?
Okay, right. So with Quarkus, Quarkus LangChain4J, the whole idea is that you configure like the AI service via various attributes on the annotation, right? Most of the attributes, they have a default value that essentially means that when there's a bean of the requested type, so like a bean of like chat memory something, then the AI service will use that bean, right? So the idea in Quarkus is like we provide you a default, which is like in memory and like message window configuration or something like that. But then you as a user, all you have to do, you can override, you can just declare a bean, and then that will apply to all AI services, right? But if you want your specific AI service, like if let's say you have multiple, and you want your specific one to have a different type of configuration, then you have to go to like the chat memory provider attribute of the annotation and specify like a new provider, which again, it could be a bean, it could not be a bean. It doesn't have to be a bean, but it's usually easier to have it a bean, stuff like that. So it's fully configurable with defaults that are easy for you to get started, right? Obviously, we can't anticipate what the proper defaults are, what the proper configuration is for
convention of a configuration.
Yeah, exactly. So our idea was like we want people to get started like super easily. Like so when you get started super easily, especially for developers who never used this before, it really creates a good feeling for developers. Like I can get productive right away, right? I just want it to work. I don't want to configure like 15 different things in order just to talk to ChatGPT the first time, right?
So we have to put annotation on AI service.
Yes, you write an interface, like the AI service, and then you just do register AI service, and that's exactly the same pattern with the REST client, right?
Exactly.
So microprofile REST client, you annotate with register REST client, and then all the magic happens behind the scenes, right?
Mm-hmm. Okay, and you ship with convention, and I will just change the configuration, like say the message window is just 2.
Yes.
So for that, I don't have to declare my own bean, right? I can just override the small defaults.
Absolutely, that is absolutely correct. So there is configuration that can allow you to, let's say, there are properties that allow you to configure the default. So if you just set those, there are like 3 or 4 different ones. Those will change the defaults. But if you want to opt into like a totally different strategy, then you can write your own bean, and then that bean is used for the AI service, right?
Yeah, and the different strategy could be interesting to persist, right? The
memory
to disk with Hibernate and Relay or JPA, and
absolutely. I think we even have somebody contributed like a Redis chat memory store, right? I think we have one of those, but yeah, it's very easy to write one of these. We don't provide many out of the box because like they haven't come up so far, but we can absolutely do that. And the good thing is that with these, like you can very easily create them because you can, like, for example, if you want to hibernate one, you could easily like just inject the hibernate session or the JPA entity manager in there and just like do save or find or whatever. And then it's just so easy to write.
Yeah.
Because it just reuses everything that you already have with Quarkus.
Then the JAX-RS endpoint has to be session scope then, right?
Okay, so in JAX-RS actually the session scope doesn't work, right? So currently the way we have it is session scope only works properly for WebSockets, right? That's the only place we've actually handled session scope for now. Like that might change in the future, but we'll see.
But what I could do with JAX-RS, I will have to pass my session ID back and forth, and then multiplex between the sessions.
If you want to keep the memory, you mean between requests? Yeah. Okay. Yeah. Exactly. So the current default is that the memory would be different for each request. If you wanted to keep the same memory, then it would be simply be a matter of using the memory ID field. The value of memory ID would be like the JSession ID or whatever, right?
Oh, okay. So there is that. So you have the API to swap actively.
Yes. So register AI service has the ability to use your own memory ID. There's a memory ID annotation, and then in there you can pass whatever you want, right? Anything you want.
Yeah, then problem solved because the session, because the true session scoped requires JSession ID, and then you get cookie often or whatever, and this is problematic in the cloud with the load balancers. So for me, it is better, not be a standard, but give the user the possibility to pass your own session, and then you can do whatever. Or of course, what you could do is you could keep it in memory or load it each time from Redis or whatever, right? Infinite span. Because this is even better because if you keep it in memory, you have also a problem in the cloud with
exactly
with serverless and with load balancers.
Exactly. Yeah, in the cloud, you don't want sticky sessions, stuff like that. You want to like services to come up and down depending on the load. So exactly. All those practices that like the community has figured out, like they just fit in naturally with this as well, right? Like obviously it takes some some usage from the developer, right? Like we can't like automatically know everything, so the developer has to do some stuff, like in this case, use the memory ID. But that's it, right? And or if the user is logged in, you can use like the user's principal or whatever as the memory ID.
But what we already see is a seamless integration between LangChain4J, Quarkus, and MicroProfile, because we could use JPA, because part of MicroProfile, to persist the session, or even cooler, we could validate a true JPA entities using LLMs. For instance, right, what I could do is I have an entity address and with fields, and what I can have is with bin validator, I can create my own validation, which has a cross checks of the address, then pass it to LLM and ask, is it like this is a spam, is it a fake address or existing one? I mean, the LLM doesn't know whether it really exists, but it will recognize as a spam, if there's strange fields, HTTPs or whatever. So this would be a true enterprise integration between an LLM, an existing application who uses bin validator, and make, for instance, a validation of domain objects a little bit smoother, right?
Absolutely, yeah. So that is an excellent use case, and it's absolutely very easy to put all those pieces together, because the goal, like I said, was to seamlessly integrate like the LangChain4J abstractions into the Quarkus programming model. So like anything, hopefully as a community we come up with to like enhance enterprise development, like it can fit into this pattern for sure.
Yeah. And okay, so we have already covered two services. Another one, which is crazy, but it fits perfectly with everything we did with MicroProfile, is tools, right?
Oh yeah. Tools. Well, that's huge. So tools, for those for people who are not exactly sure what tools are essentially a way for when during a discussion with the LLM, you are able to notify the LLM about what kind of capabilities your application has, and then your application, your own code, can get called with parameters specified, extracted, let's say, from the conversation, right? And I can give an example. The first example I saw with tools, which was like amazing. It's like when let's say you have like a booking system, right? And you have a chat where the user says like, I'm user such and such, and here's my booking ID, and I want to cancel, right? And then based on that conversation, without the developer having to do anything else but just like expose, let's say, some business logic with this tool annotation, the LLM can then instruct Quarkus LangChain4J to like look up the user based on the information like username, booking ID, whatever, and then also go cancel it, right? So that's just amazing.
Yeah, this is a enterprise use case. The obvious hello world use case is get weather, right? You say because LLM cannot know the current weather in Munich, so I can say, okay, I will like go to vacations only when the weather is good today, and then we'll ask you what is the weather, and then. But the ask you, this is important to note, is this is really crazy, because what happens actually is you are exposing a well-defined Java method. And the cool story is Quarkus is capable to really well-defined Java method, because I think you're using OpenAPI, right? OpenAPI to generate the descriptions?
No, actually, we don't have to do that. What we actually do is generate at build time, we generate a JSON schema. JSON schema. So very similar. Like the idea is the same thing. Like you take the method, you see the parameters, and then you build up a JSON that essentially describes the parameters and the name of the method. And what it returns.
I forgot the build time. So because you have to run on GraalVM, which is also huge. So what happens is you have an extension, and you can allowed during build time to use reflection, so you can inspect the signature of the method, and then you are creating from the metadata of the method the JSON schema, and then you pass the JSON schema or not pass the JSON schema, depending on the LLM. There can be different formats, LangChain4J will generate the right format for the right LLM because, for instance, the Bedrock or Claude has different format like ChatGPT because the messages are not standardized yet.
Exactly. Yes. Exactly.
So you are telling via Json Schema there is a remote function LLM, and you have really well described parameters and return values and the name, and LLM then say, okay, I have no idea, I'm not sure. Then it will call your function, not call your function. It will generate, this is the crazy part, it will generate a JSON message and give the message to you, and you will have to invoke it, right?
Exactly.
So,
absolutely.
And now is the second, killer feature, because you will have to do it by yourself, and I assume Quarkus does it automatically, right?
Yeah, so like if you want to take it back to what you were saying in the beginning where you implemented this, yeah, sure. Like sending and receiving the basic calls, yeah, you can obviously do on your own. But yeah, once you get into this, right, like having to tell the LLM which tools you have, which functions essentially you have, and then actually taking the response and invoking the functions and then sending that back, that let's say orchestration of the workflow, that gets super tedious. If you were like had to do that on your own for each different LLM, because like you said, each LLM has different APIs. If you had to implement this for each different one, like that would become very labor intensive, very fast.
And now the next feature kicks in, which is already existing from microprofile, because if I call my own service, usually this would be not, the booking service would be in some terrible external system, not implemented by me, which can be unstable.
Yes,
so
exactly.
what you can do now right now is, we can use our fault tolerance annotations which you already have and annotate the external service, which could be, now it's cool part, right? And microprofile REST client remote service, right? So now the LLM talks automatically. So this is what I said. The LangChain4J is similar to ASB a bit, Enterprise Service Bus, but pragmatic one. And so it invokes external service, and we can say repeat 3 times and exponential backup or whatever. And if this doesn't work, fallback method, which returns, a default message like message not available. And we can actually instruct then the LLM, hey, look, if this is not available, do this, right? So I would say this is the full circle, and the entire plumbing is actually managed by Quarkus.
Yes, absolutely. That is exactly what happened. So that is like, again, it's amazing how all these pieces like work together.
Yeah, this is crazy, actually. This is, as you know, all the microprofile specs fit so well to LLM, because LLM is nothing very similar to microservice, right?
Yeah, absolutely. So yeah, these just all fit in naturally. Now, and the other cool thing is that like they fit in naturally without forcing the developer to do almost anything, right? Like you just learn the basic concepts, a few annotations, everything just works. And that's because like things like Quarkus and LangChain4J have done all the heavy lifting like behind the scenes. And maybe tomorrow like there'll be another implementation, like there'll be maybe like a microprofile LM implementation or something like that, which will again like do a lot of work for you. But the concepts, they just blend naturally. It's amazing.
Yeah. And now, this was the terrible external system can be problematic, but the LLMs right now are also problematic. For instance, yesterday I worked with Sonnet, Claude, and it was not slow. I got throttled, and several times, but I have already pro account. So, so what I had to do is I have to wait for longer than 1 minute, interestingly, for more complex stuff. And what the LLMs are suggesting to have a exponential backup, right? So what you can do is you can wait 10 seconds, doesn't work, 20 seconds or whatever. And it's also implemented by microprofile. So unfortunately, I just used Java 21 without dependencies for fun. This was in my project. But if I would use Quarkus for that, I would be done. I will put an annotation on the LLM and it will happen automatically, right? And so this is interesting because really, the LLMs, they behave like unstable microservices right now. If you get a new model, chances are very high that it's very slow and unreliable. So if you're using older models, not a problem, because the everyone would like to try, the latest, hottest thing.
Yeah.
So perfect. So what we had, we covered tools, and I think what we should also do is RAG, right? retrieval, augmented generation, or is there any, maybe the primitives? What we covered, AI service, we covered chat memory, we covered tools. Are there any such primitives which are important in Quarkus LangChain4J?
Well, yeah, there are lower level ones, but yeah, I mean, I think that from a high level perspective, for what users are actually going to use most of the time, yeah, I think that
would be very briefly the low level, and the low levels, which ones would be?
The low level ones are like the chat language model, which is like a manual way of interacting with the LLM. Then there's the embedding model, which again you talk to the LLM to get like a vector representation of the text you're sending. Then you have like more specific stuff like the image model, where you send like an image to the LLM.
Okay.
Those are the ones that well, obviously then you have something that almost you'll never use in practice, like the prompt template, which is what you said. It's just a template where you replace stuff. But then all that stuff is like very hidden in most cases, right? You don't.
Yeah, but this is important to know, because what it means is we can customize our templates, prompt templates, and But one thing which is low level, not level, is the embeddings.
Yes.
So I think we should cover this, because what the model understands at the end of the day is a vector, actually, or set of vectors, and the entire words are tokenized. So we have tokenizer, I guess, right? So
yes.
So what means is, if you submit a text, then the text is split into chunks, which are not words, chunks.
Correct.
And the LLM calculates a vector, a multidimensional vector, which depends on LLM of these chunks. And but sometimes we have to create the vectors.
Yes.
And this is called embeddings. And the question is why we can do this. Sometimes there is a hack, if the prompt is too long, you could use vector to make it shorter. So this is one hack. But the most popular hack is in rec means, and this is also where Quarkus fits perfectly. Imagine you have already a database, let's say Postgres, right? And you have already JPA, and in this database you have your clients, and the clients have your orders or whatever. So what you could do easily now, you can read your already existing database and create for each row of the database a vector. You can vectorize the database. I don't know whether it's the right term. Vectorize maybe not, but embedize.
No, I think it's correct. Well, yeah,
vectorize.
I think vectorize is.
And you would create embeddings for every row in the database. And now the question is, now what? What we can do with it. So we cannot do anything with it, but there is a kind of a database which is called vector databases. And what they can do is they can store vectors, which is trivial, but is not so trivial is, this is the crazy part, they can calculate the distance between vectors.
Yes, exactly.
So and now what we also forgot to mention is that the vector is a vector in multi-dimensional space, and it has a meaning. So this is the crazy part. The dimensions are meanings. So if we have, for instance, the vector of Quarkus, right? The meaning of Quarkus in the context would be fast, standard, small, GraalVM. These were the dimensions of we can imagine, but not necessarily. I forgot what Quarkus actually means. This is a small thing, right? Is it like an atom or something, subatom or something like this, right? But in the context of Quarkus, in the application,
exactly.
the vector, the distance between Quarkus, Java Quarkus, and the true Quarkus would be far away. But Quarkus and Helidon would be closer to each other.
Oh, absolutely.
Than Quarkus and the atoms of Quarkus. So, and this is the huge power of vectors, because Elasticsearch back then they did full text search, and then the Quarkus would be, as atom, would be closer to Quarkus Java than to Helidon, right? So this is the part. Now,
totally.
So, and now what you can do in enterprise, this is the most popular pattern, is if the user asks something, you can create from the question another vector and go to the vector database and retrieve. This is the R. Retrieve everything which is close, right, to the question, and you get, if the user asks, I would like to build a fast micro profile application then Quarkus is very near. So it's okay. Then you will get Quarkus back, and not WebSphere Classic, for instance, right? So this is because WebSphere Classic back then didn't supported microprofile, so to
right.
be, no, yeah, and you will get the Quarkus back, but what you get back are two vectors, and what vector is? It looks like 1,000 floats, right? So this is what, so. And now comes the crazy part. You put the two vectors, go to LLM and say, hey, write a nice answer, right? So, and what LLM does, it understands the vectors and it is embedded into the prompt. So now, if you think about this pattern, so whatever we said before, you can have tools or whatever we said on top of that. This becomes, I would say, a task where you have to think through and write a lot of code. And with Quarkus, it's still not challenging. It's challenging from the business perspective, but from doing is more or less done, right? Because there's the vector database already, and so, and this is another this is the embedding annotation, or what was the annotation, for the
well, yeah, there's an embedding annotation, but a lot of the times you don't even have to use that, right? Because a lot of the times, like, you have your AI service, right? And if there is an embedding store configured, so you're like using like Postgres, PG Vector, or whatever, or any of these newer ones. What the AI service will use that automatically, right? To enhance the user's question. So what that means is exactly what you said. It takes the string that the user provides, like, I want to find out about whatever or about WebSphere, whatever, right? And then it queries the database with that, and what it gets back is a bunch of results and then those results are appended to the original question, and then what is sent to the LLM is that, like, the user says, what is WebSphere, and then answer using the following information. Then it has a bunch of information, and then the LLM just gives you back like information based on that.
Okay, so, this is the tight integrated way. But what I could also do, I could have my own bean with injected AI service, then use my embedded store, and then use a different model, two AI services. One points to GPT and the other to Claude, and my own embedding database, right?
Absolutely, yeah, you could absolutely do that. So the primitives in LangChain4J are there. You can use a chat language model, you can use the embedding model, and mix and match all those together. Absolutely. For cases where it does make sense, you could absolutely do that. Or you could have multiple embedding stores, right? Like you might have like two databases with two different information. You want to like mix and match those together somehow, or you can use multiple models, like you said, like Claude 3.5 and like Llama 3.1, 405 billion parameters. You can mix and match all those in the same code base using the same abstractions without having to like deal with the peculiarities of each model. Well, then there's a caveat there that, like, some models you need to like prompt them a little different. Like the text you actually write for the prompt would need to be maybe a little different. But other than that, like you don't have to worry about the differences between the models.
Yeah. And what he also didn't mention is to create the vector, we need another model. So, for instance, for Claude, we will need Voyage. For instance, for ChatGPT, the OpenAI embeddings model.
Yes.
So as you can see, this is already a workflow, almost like a workflow system, right? So I took the first model, then go to the next one, to the next one, to the next one, then have the results, go to the LM, and then get the result.
Yeah, exactly. So like you said, you start, if you want to do this on your own, you can get started. Absolutely. It's just like REST calls and stuff like that. But it then gets so tedious to manage all this stuff if you don't have the proper abstractions in place.
And okay, so we covered now RAG very quickly, right? This is retrieval augmented generation. So and one thing which is also on the horizon, the models are different. They have different performance, and performance speed is different speed, but performance means this is the smartness. The different smartness and different costs, of course.
Yes.
So what in enterprise already happens are so-called subagents or submodels, So what I always did actually, I organized my applications by boundary control entity, which was invented by Ava Jacobson a long time ago, and this was my way to hack the meetings, because I never had to discuss why I'm doing this. I always pointed to an old book and could focus, on my stuff. And the idea was boundary control entity. Boundary is the facade. Control is like, small methods which could but doesn't have to be reusable. And entity is the persistence, domain data, whatever. And in this particular case, what we could do is we could have on bigger model or smaller model. This is we don't even know. And there's a prompt, and the model, the facade model, decides which smaller model can answer your question the best. So, and then you can have a routing. You can go to Claude Opus, which is the most expensive one for heavy tasks, and the Sonnet or the Haiku, which is the fastest one and the cheapest one, and the prices are orders of magnitude. They're like 10 times cheaper or more expensive. And this will also happen. And in this particular case, is also not a problem, right? Because with microprofile, this is standard. So we have one application and we have a tool, and this tool would select different models. So this is the job of the first one. It's like, hey, look, small Haiku, your job is to decide which model does the task the best, and ask me if you would like to know which models are installed. So, and you could do the models with the description from the vendor, put in your JSON schema, and we are more or less done. So and this experimentation, this is why it's needed, because if this changes, I change the description, you generate for me a different JSON schema, and I'm already set, right? So this is
exactly
the interesting part.
Yeah, so there's a lot of things that, like, I'm sure, like the industry, like, we haven't even thought of yet, like using LLMs to drive other LLMs, or to like reformat things and then send them to the LLM. So yeah, I'm very excited about like what people can come up with using this stuff without having to deal with all the lower level stuff, right?
There's also one use case, which is killer use case for LangChain, and also LangChain with Quarkus, as microprofile is. You can also create the embeddings, not for a database, which is more or less easy because you can iterate with JDBC or JPA rather than for PDF.
Yeah.
And if you have large document, and of course, if you have 100 pages and you create one vector, the vector cannot be precise. So the question is, what is the best chunk size for vectorize your PDF document? And nobody knows. So you need some experimentation. Yeah. Sometimes paragraphs, view sentences, it really depends also on the text. But the entire tooling ships with LangChain4J and so Quarkus. So what you could do, you can say, okay, I think it's called Tika importer. So what it will do, it will extract for you from PDF the plain text. And then you have already the paragraph, right? And exactly. And then there is, I forgot the name, like iterator or something. And the iterator can iterate, the chunks. So it walks through the text, creates the pieces. You send the pieces to the embedding model. You get, you get the vector back and put it to the vector database. And this is also, a lot of experimentations. I would say LLM, it sounds easy, but you will find yourself, to tune a lot to achieve the best results. And this tuning means configuration changes, not necessarily rewriting the entire application.
Yeah, absolutely. So especially with RAG, you need to do a lot of tuning, a lot of experimentation to figure out like how to get the best results for your data. And that's like exactly what you said. If you just change a few properties and try again without having to like rebuild everything, that's where Quarkus shines additionally, because it makes this change and experimentation workflow so much easier, right? You don't have to rebuild everything and start everything again.
One killer feature you didn't mention of Quarkus, right? So the Quarkus in Def Mode, in Def Mode has a prompt, right? So you can play with LLMs without writing too much application. So you have in Def Mode, you can put the prompt in the Dev console.
Yes, absolutely, yeah. So we're trying to add more and more features to the Dev console for Quarkus LangChain4J, because exactly like you said, there's just so much stuff you need to potentially like play around with before actually writing anything. So you don't have to, in this case, like you just start the application, just to add Quarkus LangChain4J, open up the dev mode, and like start writing prompts in there, right, and see what happens. And if you have tools or if you or RAG, then we actually give you like exactly. We show you in the graphical format exactly what happens, like what's being sent to the LLM when you have RAG or when you don't. So it also makes the experience like it gives you a better understanding of how things work.
Yeah, but the DevTools they even support image generation, so this is crazy. Actually.
Yeah.
So what you get with the DevTools of Quarkus is just you have almost like your own ChatGPT, without writing anything. So this is actually cool.
So exactly, like I don't even have ChatGPT. I don't have a ChatGPT account. I obviously have an OpenAI account for the REST APIs, but then I just use the Quarkus Dev UI to write stuff or to generate an image for me, and it just works, right? I mean, sure, it's not as cool as ChatGPT, but it just works, and I don't need anything else. And the image generation thing is people when they see it in conferences, it's always really funny, right?
Yeah. And because it's extensions, also this Quarkus extension, the entire LangChain4J, it is also comparable to Graalvm, right?
Absolutely. So, like in Quarkus, we try really, really hard to make every extension work in native, and that was what we set out. Like once I started working on this, like we need to make this work in native, like from day one, right? And it does. It absolutely does because we leverage all the cool stuff that Quarkus has, so like REST client underneath for the calls and all the other REST client, all the other micro profile stuff that we just have working. So everything like you build an application, we generate a ton of code in build time, and some of the stuff we register for reflection. So when you build to GraalVM and run it, everything just works, right? Just the same as it does for a regular JVM application.
Mm-hmm. And this means you will ship everything with one file, which includes Java, Quarkus, and the entire integration, and we start immediately. And
it starts in like 10 milliseconds, so like depending on the machine. It starts amazingly fast, consumes very little memory. Yeah, it's some of the use cases are just amazing with it.
Mm-hmm. And now the what also happens right now is this is independent from Quarkus and also independent from LangChain, but also crazy actually. So Java 21 and later becomes more and more powerful, and there is an API called Vector API. And with the Vector API, you can actually read models natively. So because you can actually have or read models natively, this was wrong. You can perform metrics calculations. You have inference locally, but with the Vector API, you can have metrics multiplications very fast on CPU, and you can parse the model and perform the metrics multiplications. So what it means, we have already Llama for Java 3. Which runs without Python, without JNI, without anything. So, and what we also have, the most powerful vector database is JVector. It's written in Java, pure Java. It is the fastest one. So we can have a local inference without calling anyone. So we could actually build an application, pure Java application, which is offline standalone, which is smart. This is based on not vectorized, quantized Llama model, which is not as exact as the real one, but is good enough for some cases.
Yeah, exactly.
And you can run it without external dependencies. I would say, and this is crazy for enterprises because privacy is there. Everything is stateless, everything's a machine, no external connection, and you can still chain the models together. And if the one model is the performance is not as great, you can always call out, go to the cloud and call the real one. But this, you can even, you have a specific audits. We have already interceptors. We can we can already the profiling, debugging, everything is already there. So I would say the mix of enterprise Java, microprofile, Quarkus, and LLM makes it really production ready for enterprises because it is all the best practices from the past apply here as well.
Yeah, I mean, I think the future is going to be great for Java in this space as well. I mean, like you said, JLlama, amazing. Like in a few years when we have Project Babylon, we'll be able to do like GPU stuff. So like I think like next few years are going to be very, very good for Java.
Perfect. So it was a nice hour. So what interests me, what you are working right now with LangChain4J? Is this something specific?
Yeah. Like what I did last Friday, for example, was that Ollama released like the official release of tool support. So up until now, Ollama didn't officially support tools or like hacks, but didn't really work. So on Friday they released new Ollama version 0.30 that officially supports tools. So on Friday, like I did that, and I released a newer version of LangChain4J. So you have tools now with a local model, Ollama, that works very, very well, nicely. Now what I was doing.
So on Friday, Ollama released it, and on Friday, Quarkus released it, right? So
there was
simultaneous release.
Yeah, so like I saw it in the morning. Someone pinged me like, "Oh yeah, Ollama did this," so I started working on it. Yeah, well, obviously, like I used a lot of stuff that we already had for OpenAI, right? So it wasn't hard. But yeah, it was really exciting because people were waiting for this one, me included. So yeah, we released a version of that. Now I'm doing some stuff with. I want to make like the streaming of results a little better because like when you use an AI service, you can return a multi of string. Which that means that the LLM will stream you back results, which is pretty good. It's useful for chats. It's not useful for anything else, but it's useful for like WebSocket chats. But there are some weird cases that I think I fixed now. But yeah, lots of stuff around that. But hopefully, like for DevOps Belgium, hopefully if we get there, we'll have more cool stuff. But anyway, we'll see.
So maybe we see. I will also be on DevOps most likely. So we can have a chat and
awesome.
And what I would like to talk about is exactly what we did right now, the enterprise LLM integration. What's important from the enterprise because and how to package it. In the cloud, because there is a CI/CD process, how to build it, how to test it, and what to do with it. Okay, cool. Where people can find you on the internet?
Okay, so yeah, Twitter is GEOAND86. I write some, but I mostly like see what other people are doing. Then there's Quarkus Zulip chat. So if you write Quarkus Zulip chat on Google, it's like the first thing that comes up. Like we answer a bunch of questions there. Obviously, like Stack Overflow, I watched all the Quarkus issues. GitHub, I watched Quarkus issues, and then there's like LinkedIn too. Just my name, full name. So yeah, plenty of like standard developer-oriented channels.
Okay, then thank you. It was really fun to chat with you about LangChain4J and Quarkus.
Thank you. It was excellent.